All right, in lesson 6, we're going to talk about the three forms of a quadratic function and talk about all the essential skills and pieces of information we need to know about quadratics. All of this should be reviewed from grade 10, so you should be pretty familiar with it, but make sure you really know this well and study it and review it. Review your grade 10 notes from last year too, if that helps. First, let's talk about the direction of opening of a parabola. Okay, so when we graph a quadratic function, it makes a shape called a parabola, which is sort of that U shape. All forms of the equation share the same a value, so it doesn't matter whether it's in what we call standard form, factored form, or vertex form, a will always be the same value. So if a is greater than 0, like you have a positive a value, your parabola will open up, like the first example there. If a is less than 0, here your parabola will open downwards, and you will have a parabola that opens down. Let's see here. And when we say that, this is another thing to keep in mind. Our vertex, right? Our vertex is our highest or lowest point. So in this case, you have a minimum vertex. When it opens up, it has a low point. And in this case, the second one, you have a maximum vertex when it opens down. All right, moving on. Okay, next we're going to look at the table of values. If the first differences are constant, that means it's linear. If the second differences are constant, that means it's quadratic. So let's just check a couple here really quick. So let's start with the change in y. Now, if you look over at the x's, they're changing by a constant amount already, 1, 2, 3, 4. All right, so from -7 to -2, we increase by 5. From -2 to +7, we increase by 9. From 7 to 20, we increase by 13. From 20 to 37, we increase by 17. So those aren't consistent, so that tells us it's definitely not linear. Let's check the change in y. Remember, we use that symbol delta. It's a Greek letter. It's a triangle, and in science and mathematics, we use that to represent change. From 5 to 9, we increase by 4. From 9 to 13, we increase by 4. From 13 to 17, we increase by 4. So since the second differences are constant, they're always +4, right? So the change in y is equal to +4. That tells us that it is therefore a parabola. It is quadratic. And I can also tell that this is going to open up because the change in y is positive. So that tells me that it opens upwards. All right, let's check another one really quickly here. Change in y. From 195, we've decreased by 5, decreased by 15, decreased by 25, decreased by 35. All right, so those are not consistent, so it's not linear. And let's check the change in y again. And from -5 to -15, we're going down 10, down 10, down 10 each time, right? So the change in y, which is also called the second differences, are -10. So it's quadratic because the second differences are constant, and this one opens down because they are less than 0. They are negative, okay? So if the change in y is positive, your parabola opens up. So this one would be opening up, and this one would open down because it's negative. Okay, so that's the first thing we're going to talk about. All right, now let's jump into looking at the three forms of the equation. Okay, first let's talk about the most common and kind of your starter version of the equation of a quadratic function, which is called standard form. Standard form is right here, and we generally use these letters, ax squared plus bx plus c, to represent it. All right, so let's go through all the different pieces of information, and I got it all written here in the note, how you can kind of find all the important information, so I'll do one with you to review. All right, so in this case, a would be 2, b would be +8, and c would be -3. So when we're doing all our work here. All right, so the first thing I can say is that this definitely opens upwards. So it opens up because a is greater than 0, a is positive, so we know that this opens up. All right, so that's the first piece of information that's easy to get. Let's see, the next thing that's really easy to get in this form is your y-intercept. The easiest piece of information to pull out is the y-intercept. In this case, our y-intercept in standard form is always 0, c. So c in this case is -3. So our y-intercept, I'll just write it down here in the box, is 0, -3. So when we graph it, that's an easy point to graph. Okay, so there's the basic easy information to get out of it. The next thing is let's find our roots. Okay, so our roots, also known as our x-intercepts. Okay, to find those, you can make a choice here. You can either try to factor this in a factored form and find your roots that way. So if it's easy to factor, that's the fastest way. If you don't think it's going to factor nicely, or you're just not comfortable with factoring it and you want to just use the quadratic formula, would be your other way. Now this one, I'm definitely going to get some decimals, so I'm going to use the quadratic formula to find my roots. All right, so like we say here, to find the roots, set y equal to 0, then use the quadratic formula. So just to be clear, what I'm really doing here is I'm setting y equal to 0 because my roots occur when y is 0. So I'm really doing this, right? And then I'm just subbing in a, b, and c. So x equals negative b. I'll write the formula out here just to remind you from the other day. B squared minus 4ac, all square rooted, divided by the entire fraction by 2a. All right, so x equals negative 8 plus or minus the square root of 8 squared minus 4 times 2 times negative 3, all divided by 2 times 2. All right, so just to save some time here, you're obviously going to have the negative 8 out front. You're going to have the divided by 4. If you calculate everything underneath the square root symbol properly, you should get 88. Now, we can write this in simplified form because 88 we can break down into, I'm just going to kind of, because I got to squeeze work into here. 88 is the same as saying 4 times 22, and the square root of 4 is 2. So I can actually rewrite this like this, negative 8 plus or minus 2 root 22 divided by 4, and then we can divide everything by 2 here to reduce it. So if you want to give the exact value of this, this is what it would look like. Negative 8, oops, let's reduce that. That was the whole point, is reducing. I'm going to divide every term by 2 here. So instead of negative 8, it's negative 4. This 2 here cancels out, just becomes a 1, root 22, and 4 divided by 2 is 2. So this would be my roots written in radical form, simplified as much as possible. Okay, so if we want to give an exact answer, that's what we're looking for. Now, if we want to graph this, I can obviously punch this in my calculator, do the square root of 22. What's negative 4 plus that divided by 2? What's negative 4 minus that divided by 2? We're going to get 2 possible roots out here. Oops, don't want this junk, my bad. All right, so x could equal 0.3 approximately, or x would equal approximately negative 4.3. So there's my 2 roots as a decimal and as an exact answer. All right, so we've got our roots. Let me just go write that over on our over here. I'll just write the them as coordinates with the decimals for now, just so because I don't have too much room to fit it in. So one of them would be at approximately 0.3, and the other one would be approximately negative 4.3. There's where my 2 roots would be. Okay, next we need to find the axis of symmetry. Now, this is a super important formula you'll want to know. This is going to be your lifesaver. The fastest way to find your axis of symmetry is to just use this formula, x equals negative b divided by 2a. So I'm just going to write AOS all the time when I'm finding the axis of symmetry in these lessons. All right, so x equals negative b divided by 2a. So x equals b is 8, so negative 8 divided by 2 times 2. And when we calculate that all out, negative 8 divided by 4 should give us negative 2. So that's where our axis of symmetry is. And the axis of symmetry is also the x coordinate of our vertex. So we already know one of the coordinates of our vertex. So let me write this all down. The axis of symmetry is a vertical line, just to remind you. I'm going to write that here. And you can write that in your note if you want to remember. Vertical line. Oops, why am I writing x there? Vertical line. There we go. And that also tells us the first coordinate of our vertex. So I'm just going to start writing the coordinates of my vertex here. The x coordinate is negative 2. Now we need to find the y coordinate. That would be the maximum or minimum value. In this case, since we're opening up, we have a minimum value. So let's do that now. So I'm going to find, I'll just write it over here, my minimum. All right, so it's not a maximum. And again, this is the y value of our vertex. That's why I'm just going to write next to this, the axis of symmetry is our x value of our vertex. All right, so to find this is really easy. Since you know the x value, just take it and sub it in to the equation. So let's sub it into y equals 2 times, we're going to sub negative 2 in for x, plus 8 times negative 2, oops, minus 3, I was going to put plus 3, there we go. Calculate it all out, we'll just save time, and we get negative 11. All right, so that would be my minimum value. So I'm going to write minimum here. If we're asked if it's a minimum or maximum, it's a minimum because it opens upwards, right? And the y value is negative 11, which gives us the y coordinate of our vertex. So we have our vertex done now. Done. Okay, to finish off, I just want to draw a quick rough sketch of this. So let's put all the important information we know on. We know our vertex is at negative 211, so I'm just going to say that's kind of over here somewhere. There's my vertex at, I'll just write vertex, all right, vertex here at negative 2, negative 11. It also, we know our y-intercept is at 0, negative 3, so we'll just say that's around there. There's 0, negative 3. That's my y-intercept. We know the x-intercepts are our roots. Now these are just approximate numbers, so we're just going to put one here and one here. One x-intercept is at 0 over 0.3 up. The other x-intercept is over here at 0, negative 4.3. And there's all the pertinent information here. We could also draw in our axis of symmetry. So I'm going to draw that in right now. I'm just going to draw a vertical line going through, oops, my vertex here. Not the greatest job. Sorry. There we go. And I can label that with x equals negative 2. And we can draw our parabola now. So I'm just going to draw a quick parabola through here. Here we go. Not the greatest. I'm going to have trouble drawing with this. Plus, I didn't really put my points in a good spot. So really, it looks like my y-intercept's not in the best spot in my drawing here. All right, not the best parabola I've ever drawn, that's for sure. My y-intercept, maybe I should have drawn one first, is closer to right there than where I drew it. Just get rid of this. Oops. All right, you get the point. There we go. Okay, so not the most perfect parabola, but you get the point. So if you need to graph a parabola or you're looking for pertinent information from standard form, there's how you can find everything. Okay, so let's move on to the next form and talk about, hey, how can we find all this stuff? Oh, before we move on, we got to talk about domain and range. Sorry about that. Okay, so domain, don't forget, is what can your x's be? Well, if you look at the equation, you can make x anything you want. And this is standard for all our quadratics, unless there's some special circumstances. So remember, we write x as an element of the real numbers, means x can be any real number, just no imaginary numbers like the square root of a negative or anything weird like that. And the range, well, you can figure the range out by looking at the graph. We can also figure out the fact that we know it opens up. So y has to be greater than something because it has a minimum, greater than or equal to. And what's the lowest it goes? Well, that's our minimum, negative 11. So look at the graph if you want, right over here. It goes as low as negative 11, or you could just look at your minimum right there that we figured out. So there we go. There's our domain and range. All right, now let's move on to the next form. Okay, now we're going to look at one in factored form. So the standard, although some different textbooks use different letters, but we're going to use y equals a x minus r x minus s, all multiplying. Now, some textbooks use p and q instead of r and s. It really doesn't matter. I mean, s isn't ever really a great idea to use as a variable, but that's what your textbook uses, so we're going to use that so it matches up. All right, so first of all, what's a? There's a. Now, we got to be careful. It's x minus r. So r is actually 3. And s is actually negative 5 because it's the opposite sign, right? Now, it doesn't really matter who's r and who's s. The fact is those are my roots. And we got a is always the same. It's always out front in all versions. So let's get a out of the way. We just said a is also positive again. So that tells us that this opens up. And if it opens up, that means, oops, didn't mean to delete all that. If it opens up, that means we have a minimum value again. All right. If it opened down, we'd have a maximum. Now, we also know right off the bat what our roots are. So our roots are, that's the nice thing about factored form, are 3 and negative 5. So if we wrote them as coordinates, it would be 0, 3, and 0, negative 5 on our graph. So you know what? I'm going to go put those on my graph right now. 0, 3, we'll just say is somewhere over here. And, oops, oh boy, sorry. There's 0, 3. There's one of my x-intercepts or my roots. And we'll say 0, negative 5 somewhere over here. All right. Okay, so we got that out of the way. Next thing. Okay, the next thing, let's find our y-intercepts. So to find the y-intercept of any equation you've ever encountered, straight lines, parabolas, sinusoidal, it doesn't matter what function you encounter, you just set x equal to 0 and you solve for the y-coordinate. So let's do that. So let's find our y-intercept. I'll just write y-int for short. Y equals 3 times 0 minus 3 and 0 plus 5. So we're going to have, in the end, what's 3 times negative 3 times positive 5? We're going to get negative 45 is my y-intercept. So if I write that as a point, it's 0, negative 45. Done. So that's going to be really low down. So this graph is not going to be very accurate. So we'll just say it's somewhere down here. I know it's not accurate at all what I'm doing here. All right, 0, negative 45, and that's our y-intercept. Okay, next, let's find our axis of symmetry. We already got the roots. We got those out of the way. They're given to us, so that's done. Let's find our axis of symmetry. The axis of symmetry, the fastest way to find it in factored form instead of, like, you could simplify this into standard form and find everything that way if you prefer. But the fastest way is you just find the midpoint of your roots, right? So add the two roots together and divide by 2. So let's do that right now. So our axis symmetry, I'm just going to write AOS, which is the x-coordinate of our vertex, and it's also a vertical line. X equals, add the 2 together. What's 3 plus -5 divided by 2? So we end up getting -1. So there is my axis of symmetry. So it's a vertical line, x equals -1. So if I want to draw that on my graph, I'll do the best I can here to draw a quick line. There's a vertical line somewhere here. I know this is not super accurate. I'll just move it over a titch here, and we'll say it's about there. Ooh, about there. Okay, good enough. X equals -1 is my axis of symmetry. All right, now to find the y-coordinate of our vertex, which is our minimum value in this case, it's the exact same thing as before. If you have your axis of symmetry, just sub it in and find your minimum. So we're going to find our minimum, which in this case, all right, it's always going to be our y. Okay, so let's just sub in. Y equals 3 times -1, oops, minus 3, and -1 plus 5. All right, so we're going to go, what's 3 times -4 times +4? And we end up getting -48. All right, so that's our minimum. Y equals -48. And with the axis symmetry and the minimum value, we just put those together to make our vertex. Our vertex is -1, -48. So again, this is going to be pretty inaccurate. We'll just put it kind of down there. There is my vertex, which is -1, -48. All right, I found everything I need. Let me just do the best job I can here to try and draw a parabola through this. It's not going to be super accurate because we're just doing a rough sketch right now. If we had some grid paper, we could do a better job. Although with these numbers, they're pretty low. All right, so there we go. There's a pretty sloppy parabola. When we do some real parabola graphing, we're going to have to do a bit neater job than that. But I'm just trying to get a quick sketch out to visualize where all this information is. Okay, domain. Nice thing again, x is always an element of R for these. The range, however, let's look at this. Now it's opening up, so y has to be greater than or equal to the lowest point, and the lowest it can be is our minimum at -48. Okay, so there's the second version of a quadratic equation. So we got standard form, factor form. Let's look at the final version for this lesson, which is vertex form. Okay, here we go on vertex form. The standard version of vertex form is y equals a times x minus h squared plus k. Now again, in your old textbook in grade 10, they might have used different letters than h and k, but that's what we're going to use because that's what your textbook uses. So it really doesn't matter what letter we use. It's the same thing. So let's identify everything here. A is -2, so it's the same A as always. So right off the bat, that tells me since A is negative, that this thing opens down. And I also know from that if it opens down, that instead of having a minimum, this time we have a maximum value. So I'm just going to write max here. Okay, now what is h? H, again, it's x minus that. So we have a negative here. So it's basically whatever the opposite sign of what you see there. So h is going to be equal to 3. K is exactly what you see though. So in this case, k equals -8. All right, so the good news is, let's just get our vertex right out of the way. Vertex form is called vertex form because that's your vertex. So, oops, I'm missing the n on down here. So that tells me, let's just jump to here. My axis symmetry is given. My minimum maximum is given. They're h and k. So my axis symmetry is just x equals 3. My minimum value is y equals -8. And the coordinates of my vertex are 3, -8. So I can go graph this. So I kind of got a graph set up over here. Here's my y-axis. Here's my x-axis. And we'll just say 3, -8 is, somewhere around here. Again, I'm just doing some rough sketches for now. So there's my vertex, 3, -8, and that's my vertex. So the nice thing about this is you got that right away. It doesn't give us the roots though. Now since this one opens down, I know it's going to have no roots. Like if I tried to do the quadratic formula, I'm going to get no solution because it doesn't cross the x-axis. It opens downwards. So it's going to look something, I don't know where that y-intercept's going to be, but it looks something like this. Okay. Let me do it in a different color so it stands out a little bit more. Let's just, whatever, use green. Okay, there we go. Not the best parabola, but it'll have to do for now. Okay, so pretty easy. Now, again, in this one has no real roots. Now, how would we find the roots normally? We're going to talk about that a little later. You can do two different things. You can just put this and simplify and put it in standard form, and then you can use, so one method is simplify right? Simplify and use the quadratic formula if you really need them. But another way is, and we'll talk about this in some future lessons, is just, again, set y equal to 0, right? And then you would use the opposite operation. So I'll show you I'll show you now what this looks like. And then, unfortunately, we'll get no real roots. But I'll show you what this looks like, because you know what? It is important to show you right now before we move on any farther. Okay, so let's do that. Let's find our x-intercepts, also known as our roots. Okay, so to do that, here's what we're going to do. We set y equal to 0. Right? Because our x-intercepts occur on the x-axis when y is 0. All right. So, oops. Sorry, guys. Jumping around here. -2 x minus 3 squared minus 8. Okay. And then what we're going to do is use inverse operations to isolate x. So just solve for x. So this should be pretty easy for you. We're going to add 8 to both sides, right, to get the 8 moved over. Okay. Then we are going to divide both sides by -2 to get rid of the -2, get rid of divide by -2, so we have -4 equals x minus 3 squared. All right, then we're going to take the square root of both sides, and we could have a positive or negative value. Now, this is why we have no real roots, because we're taking the square root of a -4, right? Now, that won't always be the case, but I'll just keep finishing it just to show you how you'd finish it off. And the last step is, to get rid of this -3 here, we're going to add 3 to both sides. So 3 plus or minus the square root of -4 would be my roots. So these are imaginary roots, because, like we were just saying, you got a negative under the square root, right? There's no real roots. Okay. Now, if I didn't get a negative, let's just say I had a +4 there, then my 2 roots would be, one of them would be x equals 3 plus the square root of +4, but it's really a negative, and the other one would be x equals 3 minus the square root of -4. Right? And I could calculate that, put it in my calculator, get the decimals out. In this case, it's a square root so that of a negative, so that just tells me I have no real roots. Remember also that b squared minus 4ac, right? When we have a negative underneath the square root symbol, there's no possible value. Okay, so we've got, we're just going to write up here, no real roots. No real roots. We have imaginary roots, but we're not graphing in the imaginary plane right now. That's a whole another world of math that we're not going to touch quite yet. All right, so finish it off. Let's find the coordinates of our y-intercept. It's the same as usual. Set the x equal to 0 to solve for y. And again, these two things are true for any equation. How do you find the y-intercept? You always set x equals 0. How do you find your x-intercepts? You always set y equal to 0. It's any equation. It doesn't matter if it's a straight line, a parabola, exponential, anything you encounter. So these are two things you should know. Like any math teacher should be able to ask you, how do you find your y-intercept? How do you find your x-intercept? Right? This is our x-intercept. And you should know that. That's like a given. You have to know at this point. You're moving into grade 12. You should know that like nothing. Okay, so to finish it off, though, let's find those y-intercepts. All right, so my y-intercept, like we just said, set x equal to 0 and solve. Pretty easy, right? -2 times 0 minus 3 squared minus 8. So what do we have? 0 minus 3 is -3 squared is -9. We've got -2 times, +9 minus 8. So we end up with -18 minus 8. We get -26. So the coordinates would be 0, -26. So I'm just going to say, I know it's not drawn accurately, that's where my y-intercept is at 0, -26. All right, so domain, once again, x can be any real number. The range, this time y is opening down because the parabola opens down, so y is less than or equal to 0. So y is less than or equal to the highest point, which is -8. And there you go. There are the essentials for this unit. This lesson is so important because this, whether you're doing a word problem, no matter what you're doing, it's the same stuff. Look at the equation and what form is it in? Is it in standard? Is it in factors and vertex form? All right, how can I find the pertinent information? Because every question revolves around finding these things. It's either about finding the y-intercept, it's about finding the roots, it's about finding the axis of symmetry, it's about finding the minimum or maximum, or what the vertex is, or what the range is. Every single question is just about finding these pieces of information. And your job is to look at it and say, all right, what am I looking for? And go looking for this stuff, okay? And it helps to draw a picture, especially when you get to the word problems. Don't just do it all in your head. Don't just do it, on the paper with no picture. Draw a diagram. It doesn't make you seem dumb. It makes you seem smart to draw a picture. Some people think like it's like something they need like they feel foolish, like they need to rely on it. And I've never really quite understood that. Like, it shows you understand what's going on because you can draw a depiction of what's happening. So don't be afraid to do that. All right, guys, thanks for listening. And again, feel free to ask questions and leave comments on EDSB, and I'll do everything I can to help you.